Here are some examples of adding two rational expressions that have different denominators, or unlike denominators. In this first one, we've got 5 over 4x plus 2 over 3x squared, and we're told to add. So notice first of all that the denominators are not the same. We don't have a common denominator yet, so we've got to get a common denominator. So I'm thinking to myself, can we factor 4x or 3x squared at all? Because that's always the first step in finding the common denominator is factoring all the denominators completely if necessary. And there's really no way to factor 4x or 3x squared. We could factor 4 as 2 times 2, but it's okay to just leave it as 4. So what would the least common denominator be? The least common denominator among these two denominators is always the least common multiple of the two denominators. So looking at a 4 and a 3, the least common multiple of a 4 and a 3 is 12. So we would have to have 12 for the least common denominator. And looking at our x and our x squared here, we would have to have x squared. You always go with the higher exponent when faced with a choice between factors that are to two different powers. This is x to the first power in the first denominator, and this is x to the second power. 2 is larger than 1 for the exponent, so go with x squared for the common denominator. We need to convert both fractions into something over 12x squared. So for our first fraction, we've got 5 over 4x. And I'm thinking to myself, what could I multiply 4x by to convert it to 12x squared in the denominator? So that would be 3x. 4x times 3x is 12x squared. We need to multiply the numerator and denominator of the first fraction by 3x. And then for the second fraction, we've got 2 over 3x squared. What could we multiply the 3x squared by to convert it to 12x squared? And that would be 4. 3 times 4 is 12, so 3x squared times 4 would make 12x squared. So the numerator and denominator of the second fraction have got to be multiplied by 4 to obtain the common denominator. So the next step is to multiply 5 times 3x in the numerator to obtain 15x, and 4x times 3x in the denominator is 12x squared. So we have 15x over 12x squared for the first fraction. And then for the second fraction, 2 times 4 in the numerator makes 8, and 3x squared times 4 makes 12x squared in the denominator. We now have the same denominator underneath both fractions, which means we can add them together. So let's add them together and make it a single fraction. 15x plus 8 is the new numerator, and the denominator is 12x squared. So we've got 15x plus 8 over 12x squared. Sometimes at this stage we're done, but to make sure that we're done, we have to see if we can potentially factor the numerator and then maybe reduce to lowest terms. I don't think we can factor 15x plus 8 at all, so at this stage we're done. Here's a second example of adding two fractions with different denominators. In this one we've got 9 over x minus 3 plus 6x all over x squared minus 8x plus 15. The very first thing to do is to factor both denominators completely, if necessary, and the second denominator needs to be factored. So we've got 9 over x minus 3 plus 6x over, I'm creating two factors here to try to factor the trinomial. X times x would make x squared, and what times what is 15? That adds up to negative 8. That would be a negative 3 and a negative 5. Okay. So the second denominator factors as x minus 3 times x minus 5. Looking at our two denominators now, we have x minus 3 and then x minus 3 times x minus 5. The least common denominator of these two fractions needs an x minus 3. There's a single x minus 3 in both denominators, so we need a single x minus 3 for the common denominator. And the common denominator also must have the x minus 5 factor from the second denominator. This is our goal. We want both denominators to look like this, something over x minus 3 times x minus 5 for both fractions. So for the first fraction, 9 over x minus 3, what do we have to multiply the denominator by in order to obtain our common denominator here? Well, it's already got the x minus 3. It needs the x minus 5. So we need to multiply the numerator and denominator of the first fraction by x minus 5. And I'm enclosing those in parentheses just to remind us that we need to distribute the 9 and have parentheses around both of our binomials in the denominator. Plus, our second fraction is already over top of the common denominator, so we don't need to multiply the second numerator and denominator by anything. We can just copy the second fraction down as is. 6x over x minus 3 times x minus 5. So let's multiply the 9 by the x minus 5. Here we have 9x minus 45 all over x minus 3 times x minus 5. And we're adding to that 6x all over x minus 3 times x minus 5. It's time to add the fractions together. We now have a common denominator, so we can write it as one fraction. It's 9x minus 45 plus 6x. That's our numerator, all over top of x minus 3 times x minus 5. Occasionally we're done at this stage, but we need to simplify if possible, and there are like terms to combine in the numerator. So let's combine the x terms in the numerator. 9x plus 6x makes 15x, and then minus 45. 15x minus 45 all over top of x minus 3 times x minus 5. And then sometimes at this stage we're done, but we need to take a look at it and just potentially see if we could factor the numerator and maybe reduce by canceling a common factor. And I think the numerator has a common factor of 15 that we can factor out from both terms on top. So let's factor out a 15 in the numerator. That leaves us with x minus 3, because 15 times 3 is 45. And that's all over top of x minus 3 times x minus 5. And then we can reduce by canceling the common factor there of x minus 3. So x minus 3 divided by x minus 3 is 1. We can reduce those. And our final simplified result here is 15 over x minus 5.